everybody. This is Mr. Salent with my daughter Shenna and Denali. She's going to be our video recorder, and we're going to try something new. We're going to try to post the solutions to the homework online, and I will go through the problems. So if you don't understand how to do them, hopefully the explanations will make it a little bit clearer. And let's try. Here we go. All right. Okay, Shenny. Okay, here we go. Here's an achievement scale for the waves units, and I've crossed out the things that we decided not to do this year. So in the A level, we've not done can order the EM spectrum, so you won't be responsible for that, and you won't have to diagram wave interference. We haven't done any of that. At the B level, the only thing we've not done is destructive and constructive interference. At the C level, it's identify the components of the electromagnetic spectrum. Everything else we've done there. Likewise, if you look over to the vocab, you are not responsible for the electromagnetic spectrum, constructive interference, or destructive interference. Everything else is on the test. Okay, everybody, problem number 10. Is there wave motion? Wave motion or harmonic motion is motion that repeats over and over and over. The difference between wave motion and harmonic motion is we'll talk about in number 11. Harmonic motion of a pendulum. The pendulum's not going anywhere. We think about the baseball that swings in the room. It's just going back and forth, but it's not moving like the wave on a spring, which moves from one place to another. But regardless, let's just think, is there harmonic motion involved in any of these? So your radio picks up a signal from a radio station. Those are radio waves that the station is beaming to you through the air. So yes, that is wave motion. Music that comes out of your radio is a sound. Sound is our best example of a longitudinal wave. So yes, music has wave involved. A car going 70 meters per second down the highway, that is not repeated motion over and over. That's just a car moving in what's called linear motion. So no, a car going 70 meters per second is not a wave. Earthquakes. Okay, these have been shown, and I think you learned in 8th grade that you have S&P waves in earthquakes. So yes, those are waves. Ocean waves, I hope that was easy, goes without saying. An ocean wave has a crest, a trough, an equilibrium, etc. A bulldozer moving down the dirt, I guess. Again, just linear motion. It doesn't have a crest, trough to its motion. It doesn't repeat over and over. So that is no. And finally, music. Well, I guess we already had music, so yes, that's a sound wave. Okay, so here we go. Problem number 11 is a pendulum. So think about the baseball that's swinging back and forth in our room. One cycle of the pendulum. A cycle is one part to another, the same part. So on a wave up here, if you look up here, Denali, we can see a wave. One part of the cycle to the next same part is crest to crest, trough to trough, or middle position going in the same direction, middle position. So if we think about a pendulum, it's when it starts, it swings out, and swings back. So one cycle of the pendulum would be from, if we started at C as the problem says, C to A, back to C. So C to C is one cycle. Half of that cycle would be A to C. And the amplitude is the equilibrium position, where, now when we looked at a wave, we've talked about water waves. If the wave died out, the water would just be at the middle position. If a pendulum stopped swinging, it would be resting at the bottom, the B position. So the amplitude of a pendulum is from C to B, highest point to the equilibrium position. So that would be C to B. All right, for the next 5 problems, 12 through 16, we have to apply 2 equations that we're responsible for in this chapter, or this unit. It's here, I'm showing you the triangles. Velocity equals frequency times wavelength. In here, it is period equals 1 over the frequency. So our base equation for this triangle is period equals 1 over the frequency. And the equation that everyone has to memorize for this is velocity is frequency times wavelength. Oftentimes it'll ask for speed. Instead of velocity, it's pretty much the same thing. Remember, velocity is just speed with a direction. Okay, so here are the problems. The wavelength of a sound wave is 3.5 meters. So again, I want you to underline what they tell you. The frequency is 750 hertz. What is the speed? And then I circle what they're asking for. So the question is, what is the speed? So speed equals, we look at our equation over here, frequency times wavelength, or our triangle. Frequency times wavelength. That is a core equation you have to know. This is three-step math. Speed equals 750 hertz times 3.5 meters. You plug in your numbers, so that's step 1, that's step 2, and then you go for the final solution. Now you will be able to use a calculator if you have it. If you don't bring it to the test, well, then you're going old school. So 750 times 3.5 is 2,625. The units for speed are meters per second. So that is the speed of the wave. Okay, back we go. Question number 13. Again, we have our two triangles over here. These are what we are going to be using. Underline what they give you. Frequency is 25 hertz. How many waves? I always circle what they're asking you. Pass a certain point in 3 seconds. So what we have to ask ourselves is, what are they really asking for? So how many waves pass a certain point in 3 seconds? The definition of frequency is number of cycles per second. That is its definition written in math, and I said it in English. Number of waves per second. So, if the frequency is 25 hertz, that means it's 25 waves every second. So if there's 25 waves that happen every second, how many waves happen in 3 seconds? 3 times 25 is 75 waves occur in 3 seconds. Okay, here we go. A wave completes 2 cycles every second. So they gave us that. The speed of the wave is 1,000 centimeters per second. What is the wavelength? So we know the speed, 1,000 centimeters per second. The question is, what is this? 2 cycles every second. So remember, so that's 2 cycles every second. If we looked up here, show up here now, that's the definition for frequency. Frequency is the number of cycles per second. So we have been given the frequency and the speed. So if we look over here to our triangle, what is the wavelength? Well, wavelength is velocity divided by frequency. So wavelength equals velocity divided by frequency, which is 1,000 centimeters per second divided by 2 hertz. And the answer to that is 500 centimeters. Now, if you don't want to use your triangle, I understand. If you understand the algebra here, velocity equals frequency times wavelength. Velocity was 1,000, frequency was 2 times wavelength. To get rid of the 2 on this side, we divide each side by 2, and then we have wavelength equals 500 centimeters. Same answer, it better be one using the triangle and one using just algebra. Alright, here we go. Number 15. A guitar string vibrates at 175 cycles per second. 175 cycles per second. If we looked up here, the number of cycles per second was the definition of frequency. So back down to here, this is frequency. calculate the period of vibration on the string. So let's circle that, calculate the period to keep within our system. Period is equal to 1 over F. This is one of our core definitions over here. We've been given F, so period is equal to 1 over 175 hertz. Again, that's some difficult math if you don't have your calculator, but if you don't want to bring it, that's up to you. So let's say 1 divided by 175. So the answer is 0.0057. Period. Second period, sixth period, seventh period, these are all measured in time. So period is a measure of time. So this unit is seconds. So the answer is 0.005 seconds. So it takes 0.005 seconds for every one wave. All right, here we go. Last one, number 16. A wave has a period of 15 seconds. The speed is 300 centimeters per second. What is the frequency? And what is the wavelength? So it's asking for two different things. So frequency, if we look over here, period is equal to 1 over the frequency. Using the triangle, frequency is equal to 1 over the period. You don't have to do this. You can use the algebra, but I'm just going to write frequency is equal to 1 over the period. Frequency is equal to 1 over 15 seconds. And the unit of frequency is hertz. So let's put the unit there first. If you bring your calculator, you just 1 divided by 15 and we get 0.067 hertz. That is the frequency. Three-step math. The equation, plug in the numbers, there's your answer. Now, the second part of this question is, what is the wavelength? So if we again look at this triangle, you don't have to do this. Algebra is great if you understand the algebra, but the equation for wavelength is velocity divided by frequency. So wavelength is equal to velocity divided by frequency. We were told that the velocity was 300 centimeters per second. The frequency we found was 0.067 hertz. So the answer to this question would be 300 divided by 0.067. And with that, we get 4,477.6. The question is, what is the unit? It's wavelength. So what length is in our problem? Centimeters. So the answer is 4,477 centimeters. All right, here we go. Problems 17, 18, 19, and 20 are analyzing graphs. So let's do it. The first thing you always should do, mark the equilibrium position. Equilibrium position is the equal position. So equal up, equal down. It's not always the middle position, or it's always the middle position, but not always zero. So be very careful there. Now, there are three basic shapes a wave can have. There's the classic S shape, there's the crest to crest shape, and there's the trough to trough shape. Okay, so those are the three shapes, one cycle. So these are all one cycle. Okay, so we start at 0, so we're going to be looking at the equilibrium to equilibrium. So if I start at 0, I have to get my classic S shape. That is one cycle right there. Okay, now if I'm counting the number of cycles, that's 1, that's 2, that's the classic S shape, and then that's only a half. It's only the top part. It's only this part right here of the classic S-shaped wave. So that is 2.5 cycles. The amplitude, middle position to a crest or trough. So we start at 0 and we go up to 5. So that is 5.0 meters. If you put 5, you got half credit. 5 meters, you get full credit. Period. The time it takes for one complete cycle. So time in seconds is down here. We said this is one cycle and it took 2 seconds. So the answer is 2. If you put 2, you get half credit. 2 seconds, you get full credit. Frequency is equal to 1 over the period. We just said the period was 2 seconds, so the frequency is 1/2 of a hertz. Wavelength. You cannot tell the wavelength on this graph because the x-axis is in seconds. So you cannot tell So put can't tell for the wavelength.